Hello everyone, this video is about complex number past paper questions. Number 1, the complex number u is given by u equals minus 3 minus 2 root 10 I. We need to find the square root. So we call it a plus bi, square both sides, equate the real part and the imaginary part, and we have two equations into variables. From here you can substitute the a, and then you can solve the quadratic. We get the value of b, and plug in here, you get the value of a, we get the square roots. And for b, sketch z minus 3 minus I is smaller than 3, so that would be a circle. The center is 3 1, the radius is 3, and smaller than means we shade the area. Z is bigger than pi over 4, the argument of z, so it's a half line. From the origin the angle is pi over 4, so we shade from pi over 4 to pi because bigger than, and imaginary part of z bigger than 2, so that means the imaginary part, so it's a horizontal line, I equals 2, or not I, actually the imaginary part equals 2, so 2I. For the circle, this is the individual sketch here. For the circle, the center 3 1, radius 3, and this is for the half line. From origin, angle bigger than pi over 4, so pi over 4 to the maximum pi here, so we don't go across the x-axis, of course, because it will be the negative angle in the principal argument. And imaginary part bigger than 2 means we shade the one above, and this is the final answer. So it's inside the circle, it is above this half line, not above, above to the left of this half line and above the horizontal line, so this is the shaded part. Next, we express this number in this form, right? So we multiply by the conjugate, complex conjugate. Minus means we use plus, we do the expansion. This is the difference of two squares, and we get this final answer in Cartesian form. Now to convert to exponential form, we find the modulus and the argument. And if you look at this negative, real, positive, imaginary, this must be in the second quadrant. In the second quadrant, we do inverse tangent plus pi. Just remember, it's got to be in the second quadrant. The theta must be in the second quadrant in the end. So this is the final answer in 2 decimal places, 3SF I mean. Now B, we need to sketch z minus this equals 1, so it's a circle, center 3 minus 2, and we need to find the least value of z for points on this locus, the least value of the modulus of z. So from here we get the circle, this is the sketch, 3 minus 2, center, the radius is 1. Now to find the least value of z, so the z is from origin to any point on the circle, so the z is some random point on the circumference. To find the shortest, we have to use the point around here, which is actually, it's supposed to be like the normal. So if you make like a straight line, it passes through the center of the circle here actually. So to find this length from origin to this point on the circle, we need to find the length of the center here. So the center is 3, 2. You can find the hypotenuse 3, 2. You get root 13 minus 1 because the radius is 1. Alright. And next, yeah, this is similar. Let's just skip this. And yeah, let's try this one. So it's given that the complex number, this is a root of the equation. If this is a root, then when you plug in this, if you replace the x with this root, you will get 0. So yeah, to find the other root, we just use the complex conjugate here. Now for I, find the value of k. We just plug in, we replace the x with, okay, but we need to find the cube and the square. So let's find minus 1 plus root 3i cubed. So we use this identity, or you can just use the binomial expansion formula to get exactly the same thing here. A plus b all cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So the a is minus 1, the a is minus 1, the b is root 3i minus 1, root 3i, minus 1 cubed is minus 1, 3 times 1 is 3 times this, so 3 root 3i, minus 3 times here, if you square it, you get 3i squared. So it's a minus 3. Minus 3 times minus 3 is plus 9. And here you have root 3 cubed is 3 root 3. I cubed is minus I. So you cancel out, and in the end you have 8 for the cube, and for the square we use the usual identity, a squared plus 2ab plus b squared, or you can just expand manually, rainbow method, you get this. So this is the cube, the square, and the linear, and we open up all the parentheses, we distribute everything and simplify, and you'll get the value of k. And the third root of the equation. Now to find the third root, remember that since minus 1 plus 3 root 3i is a root, x minus the root is a factor, x minus the other root is another factor. So if you multiply, open up all the parentheses and group the one with the real part, or the x plus 1, this is the difference of two squares, x plus 1 all squared minus root 3i all squared, we get x squared plus 2x plus 1, and from here we get 3i squared, which is minus 3 minus minus 3, that's plus 3. So we have the quadratic factor here, and we can find the quotient using long division, or just use logic here. We have x squared, we have to multiply this x squared by something to get 2x cubed. Of course it's gonna be 2x here, and this is plus 4, we have to multiply this by something to get 4, so it's just 1. Or if you can just use long division, the cubic divided by the square, you will get 2x plus 1. And if this is the factor, 2x plus 1 is the factor, the root is minus 1/2, of course. Alright, yeah, I think that's it. I'll see you again next time.